Hello students, myself Arshal Nilkanda Nemade, lecturer in Mechanical Department at Praveen Patil College of Diploma Engineering Technology. Now today I will start with chapter number 2, Process Engineering. Part 1, Introduction and Introduction to Ultra Super Critical Boilers. Okay. Learning outcomes. By the end of the chapter, the students will apply the heat engineering in process boiler, understanding ultra super critical boiler, understand hyperbolic cooling tower, waste heat recovery system used in a process industry. Introduction. Steam. What is steam? Steam is a vapor from form of the water. Steam has been a popular mode of conveying energy since the industrial revolution. Steam is used for generating power and heat in the process industry such as sugar, paper, fertilizer, refineries, petrochemical, chemicals, food, synthetic fiber, and textiles. Boiler. It is a closed vessel in which water gets converted into the steam with the addition of the heat which is generated by combusting fuel, may be solid, liquid, and gaseous, in the combination of the chamber or a furnace. Process boiler. The boiler used in the process industries for heating purpose are called as the process boiler. The pressure and temperature of the steam generated in this boiler is basically low. Process boilers are capable for generating the saturated steam at the pressure of 10 to 15 bars. The saturated steam is lead to the point of the application and latent heat rejected during the condensation of the saturated steam is used for process heating. Sensible heat of the water. The amount of heat required by the 1 kg of the water to raise its temperature from freezing the temperature up to the boiling temperature or the saturation temperature is called as the sensible heat. Is liquid enthalpy, which is enthalpy, heat energy in a water when it has been raised to its boiling point to produce the steam, and it measured in kilojoules per kg. Its symbol is HF. Q is equal to M multiplied by CPW multiplied by TW minus TI. Now where Q is the heat, M is the mass of substance, CPW means specific heat of the constant pressure of water, TW means temperature of the water after heating, and TI means initial temperature. Latent heat. The amount of heat required by the water which is at the boiling or the saturation temperature to convert it in form of vapor form or the steam at the constant temperature. Such a heat is called as latent heat. When the latent heat is acquired by the water, only the phase change will take place, but there is no change in the temperature. Latent heat is also called as the enthalpy of the evaporation. When the steam condenses back into the water, it gives up the enthalpy of the evaporation which it had acquired on the change of water to the steam. The enthalpy of the evaporation is measured in kilojoules per kg. Its symbol is HFG. In process industry, the latent heat given out by the condensing saturated steam are used for the heating application. Saturation temperature. The temperature at which the water boils, also called as the boiling point or the saturation temperature, increase the pressure. When water under the pressure is heated at the saturation temperature rise above the 100 degrees Celsius, and usually the heat energy in the steam enthalpy of the evaporation decreases. Now this is a steam phase diagram. You may see in one container cylinder there is a water. On the water there is one piston. As I heat the water is getting heat converted into wet steam. After wet steam, in third stage, the water is converted into dry saturated steam, and slowly it will get converted into the superheated steam. See the graph which is given. Liquid region is in dark color. Superheat is in light color dotted. And the portion which is in middle, it is two phase region, that is a saturated line, and saturated vapor line, and at the top there is a critical point. Steam distribution diagram. The steam distribution system is essentially link between the steam generator and the steam user. Whatever the source and the efficiency of the steam distribution system is essentially if the steam is right quality and the pressure is supplied in the right quantity, the steam using the equipment, installation of the maintenance systems are important use must be a consider of the design stage. As the steam contains in the process flow, okay, it is induced to supply the pipe contains has a very small amount volume of compared to the steam and causes the pressure drop which causes the steam to flow through the pipe. The steam generated in the boiler must be converted through the pipe work to the point where the energy is required. Initially there is a more pipes or a steam main which carries the steam of the boiler, generally the direction to the steam using the smaller plant. Okay, branch pipes can be carried the steam to individual the pieces of the equipments. Typically steam distribution system shown in figure. You may see the figure. Okay, it must be noted that reducing valve pressure reducing valve, it is known as PRV, are used to reduce the pressure of the steam as per the requirement of the process device. Okay, pressure reducing valve is used to reduce the pressure. In the you may see the in diagram there is there. Okay, feed tank is there, feed pump is there. Okay, the steam is going up. Okay, it is going in pan and getting condensed. After getting condensed, again the steam is going in a process vessel, again condensed, and the phase heating system again condensed. Okay, you may see the steam distribution diagram how the steam is distributed in a process boiler. Introduction to ultra supercritical boiler. Okay, supercritical boiler means it is critical. Okay, at the supercritical pressure, the steam turbine efficiency improves significantly compared to the typical critical cycle. Ultra supercritical steam condense provide even a greater efficiency improvements. The combination of utilizing the supercritical throttle pressure along with an increase in the total temperature result in the cost reduction in the fuel uses and handling the fuel gases, treatments and ash disposal. Black and white supercritical and ultra supercritical boiler are designed to take the full advantages of the operation. So what are the advantages you see? Okay, specific advantages include for given output, lower fuel consumption and thus the low carbon emission than the other less efficiency system. The load change rate capability of a system is not rejected by the turbine. Steam temperature at the inlet and outlet of the preheater is nearly constant over the wide load range. The boiler feed water power is significantly reduced at the lower load. Short startup of time, higher plant efficiency over the range of the. Okay, we will see some range for supercritical. Pressure is 221.1 bar and temperature is 538 or 538 degrees Celsius or 538 to 560 degrees Celsius. Okay, for supercritical, okay, that was a subcritical, sorry. First one was a subcritical. Now we will see a supercritical. The pressure is 221.1 bar to the 260 bar and temperature is 538 to 560 degrees Celsius to 566 to 593 degrees Celsius. Ultra supercritical is pressure 260 bar and temperature is 593 to degrees Celsius to 600 to 620 degree Celsius. Okay, this was the introduction to the supercritical boiler. Thank you.